Watch this dashboard. A diagnostic cable connects to the vehicle port, and a blank screen immediately illuminates with a full suite of premium applications. Automakers mass-produce identical physical infotainment hardware across multiple vehicle trims. A standard 8-inch display in a base model is physically the same component used in the luxury tier. The manufacturer gates the premium features purely through software configurations stored locally on the unit. The process of toggling these specific configuration parameters is called variant coding. You do not need to rewrite or flash entirely new software to the electronic control unit, or ECU. You are simply flipping existing digital switches from off to on. In this tutorial, we are going to use diagnostic engineering tools to access an existing ECU and enable a hidden Android Auto feature. This layout shows the required physical setup. You need a laptop running diagnostic software like DTS Monaco, an OBD2 communication cable, and the valid security credentials for your specific vehicle module. Updating these specific parameter values is the only requirement to bypass the base model restrictions and activate the hardware's full feature set. Step 1 is establishing communication. We connect the diagnostic tool to the vehicle network, typically routing through either the CAN bus or an Ethernet connection. Before making any changes, we read the general ECU information. We verify the vehicle identification number and confirm we are interacting with the correct hardware and software versions. The diagnostic tool sends UDS service 0x22, read data by identifier. The ECU returns the list of active variant coding parameters. We locate the row Android Auto. Its value reads disabled, matching the vehicle's physical reality, which currently shows no projection icon. You must identify the exact location and current state of a parameter in the software before you attempt to modify it. Users frequently cause errors at this stage by attempting to overwrite the parameter immediately. The ECU will reject the command because its memory is locked and write-protected by default. This sequence illustrates UDS service 0x27 security access. The ECU sends a randomized seed to the tool, which calculates and returns the correct key to unlock the memory. Confirm the interface displays an access granted message before proceeding. With the memory unlocked, we change the Android Auto parameter to enabled. The tool executes UDS service 0x2e, write data by identifier, pushing the single parameter update across the network into the ECU. The ECU receives the command and permanently stores the new enabled status inside its EEPROM or flash memory. Without executing the security access handshake first, the system will block all write attempts, keeping unauthorized users from altering the vehicle's permanent hardware behavior. Even after a successful write command, you will notice the physical dashboard screen looks exactly the same. The projection menu is still missing. The system is currently running on the old data cached in its active RAM. It will not read the newly updated EEPROM data until it is forced to restart. To trigger this restart, we send UDS service 0x11, which initiates a hard ECU reset. Watch the dashboard as the command executes. The screen immediately goes black, cuts power, and runs its standard cold boot sequence. Once the home menu loads, we manually navigate through the user interface. The previously hidden projection option is now visible on the screen. We plug a smartphone into the vehicle's USB port. The hardware successfully enumerates the connection and the Android Auto service launches on the display. Back-end configuration changes are completely inert. The hardware cannot validate or execute them until a full power cycle forces the system to load the new memory states. This side-by-side comparison highlights the result. We moved from a restricted, basic layout on the left to an active, premium interface on the right. This exact diagnostic workflow is used across the automotive industry to configure display resolutions, activate 360-degree cameras, and update regional map data. The final mandatory step in any variant coding process is to scan the vehicle network for diagnostic trouble codes, or DTCs. If you enable a feature in the software, like a rear camera, but the vehicle lacks the physical camera hardware, the ECU will detect the mismatch and generate a fault code. By modifying specific configuration parameters, engineers activate the full capabilities of existing automotive hardware, avoiding the severe risks of flashing entirely new operating software.